powers and exponents. But let's call this part 2. All right. So, what happens when there is a exponential expression that has a decimal? Let's do it. So, what I mean, an exponential expression where the base is a decimal. So, if I said, like, for number 1, example 1, if I said 0.72 to the third power, all right? So what am I saying here is that in this particular problem, just like before, 72 is your base and 3 is your exponent. And to expand that out, that is, just like before, 0.72 times what? 0.72 times what? 0.72 or 72 hundredths 3 times. Because remember, the power told us to write it or multiply that number 3 times. All right, so that's the expanded form. Now, excuse me. To simplify, we put that number in the calculator 3 times. 0.72 times 0.72 times 0.72. And our answer is 0.3732. All right. I'm going to ask you to round it to the nearest thousand place. Thousand place is 3 place values away from the decimal. So our answer for that is 0.373. Because 2, anything less than 5, this digit here will stay the same. All right. Anything 5 and more, that digit would have went up by 1. All right. So let's look at another one. So that's when a decimal is the base. Let's look at when there's a fraction that's a base. So the second example is like, let's do 2/5. All right. Now, if 2/5 is my base, 2 and 5, 2 or 5 is my base, then I need a parenthesis with an exponent on the outside to let me know that I'm multiplying the whole fraction how many times? 4 times. That expanded form, 2/5 to the 4th power expanded, is 2/5, and we can use dot here for times as well, times 2/5 times 2/5 4 times. All right, now, coming from multiplying fractions, we talked about how you break down everything. Well, if you are multiplying the same fraction over and over again, there's nothing to reduce. So in this case, skip to the very end of multiplying fractions. Multiply the leftover factors at the top so we can get that numerator answer, which is, remember, 2 times 2 times 2 is 8. 8 times 2 is 16. All right. Then we draw a fraction line because now we have to come down here to the bottom and do the same thing. Because nothing canceled out. We just multiply straight across. 5 times 5 is 25. 25 times 5 is 125. 5 times 125 is 625. So 2/5 to the 4th power simplified is 16 over 25. All right, one more. All right, the third example. What happens when you have an exponential expression, let's say 6, and it says raised to the 0 power? Now, some people think that just means 6. It does not, because the exponent or the power right here, the power tells you how many times to multiply this base here. And if it was a 1, then you would just write it one time, but that's a 0. So when there's an exponent that is larger than 0, like 1, 2, 3, 4, 5, then that's repeated multiplication. When you have a power that is 0, that is repeated division. This is what I mean. 6 to the 0 power is 6 over 6. All right, remember, fraction line means divide. So whenever you have a power of 0, you write the same factor in the numerator as you would in the denominator. All right, so you take the factor, write it as a numerator, then write it again as the denominator. All right, then we understand that 6 divided by 6, or remember, the same factor cancels out, and they change to what? 1. So 1 over 1 is 1. All right, I think that covers exponents part 2. You can begin completing the ones that are not highlighted. All right.